Hello, today we're going to be doing chapter 18, problem number 81. The question is, the change in enthalpy for a reaction is negative 25.8 kilojoules per mole. The equilibrium constant for the reaction is 1.4 times 10 to the third at 98 degrees, or at 298 degrees Kelvin. What is the equilibrium constant for the reaction at 655 Kelvin? So we're going to use the Van Hoff equation, which is ln K2 over K1 equals negative change in enthalpy over R times 1 over T2 minus 1 over T1. So for the R value, it's in joules per mole, so we have to change the heat of enthalpy into joules. So you just multiply by 1,000 to get 25800 joules. So then if we just plug all these values, so we have our K1, they gave us the T1, the T2, and we're looking for K2. So now we just plug it all into this reaction, or to this, equation. So it should be ln K2 is what we're looking for over K1, which is 1.4 times 10 to the third, equals a negative delta H, and so this is already negative, so it balances out. So it would just be 25800 over R, which is 8.314. And then you do 1 over T2, which is 655, minus 1 over T1, which is 298. So then, if you do this calculation, it gives you negative 5.6757 675711839. And then then on this side you have ln K2 over 1.4 times 10 to the third. So then to get rid of the ln, we're gonna raise each side to the e. So the e gets rid of that. So then you just have K2 over 1.4 times 10 to the third equals e to the negative 5.675. And so then that number gives you 0.003428228 over K2 over 1.4 times 10 to the third. So then to find K2, you just multiply these numbers by each other. Boom. So then K2 should give you 4.799512. So that your final K2 answer, since we have two sig figs, is 4.8. And there's no units for equilibrium constants. So that's your final answer. Thank you.